Hello! In today's lesson, we're looking at Chapter 10, Section 6, Equations of Circles. Our objectives are to be able to write, graph, and solve equations of a circle. Standard equation of a circle. A circle with radius r and center hk has the standard equation: the quantity x minus h squared plus the quantity y minus k squared is equal to r squared. The parent equation of a circle is x squared plus y squared is equal to r squared, and our center is located at 0, 0, which is at the origin. The h and k in our equation of the circle shows the translation from the center to some coordinate point away from the center. So when we're writing our equation of our circle, this h and k just represents where we've taken the center and moved it to. When writing your equation of the circle, think about h and k as what do you need to do to your equation in order to move your center back to the origin, which is at 0, 0. Example 1, writing a standard equation of a circle. Write the standard equation of a circle with the center 0, 6 and the radius of 3.6. Here we have the formula, which is the quantity x minus h squared plus the quantity y minus k squared is equal to r squared. This is our h, this is our k. So we're just going to plug in the h and k into the formula. It will become x minus 0, the quantity squared, plus y minus 6, the quantity squared, is equal to 3.6 squared. Simplify, x minus 0 is just going to be x, and then that's x squared. And then it's y minus 6, the quantity squared, and 3.6 squared is 12.96. When writing your equation, think of what you need to do to your h and k values in order to get it back to the origin of 0, 0. In this example over here, I don't need to do anything to the h value, which is also our x value because it's already at 0. But in order to move my y value, which is also my k, I need to subtract 6 from it to get it back to 0. And that's why in this equation you notice that we don't do anything to the x value, but in order to move our y value back to 0, we are subtracting 6 from it. Example 2, writing a standard equation of a circle. The point negative 1, 1 is on a circle whose center is negative 3 and 4. Write the standard equation of the circle. First, before we can write the equation, we need to know what our radius is. Our radius is the distance between the point on the circle and its center. Remember your distance formula, d, is the square root of x2 minus x1, the quantity squared, plus y2 minus y1, the quantity square. Here's our x1, y1, and this is x2, y2. Plug it into our equation. We've got negative 3 minus negative 1, the quantity squared, plus 4 minus 1, the quantity squared. Simplify inside the parentheses. You got negative 3 minus a negative 1, which is the same thing as saying plus 1, which gives me negative 2 squared, and 4 minus 1 is 3. Negative 2 squared is 4, positive 3 squared is 9, 4 plus 9 is 13, so we've got the radius as the square root of 13. Once we have our radius, we know our h and k values is negative 3 and 4, and our radius is square root of 13. We're going to substitute that into the standard form of the equation, which is x minus a negative 3 and y minus 4 equal to the square root of 13. Simplify your equation. Minus a negative 3 is the same thing as saying plus 3. This is just going to be minus 4, so it's x plus 3 squared plus y minus 4 squared, and then the square root of 13 squared is just going to be 13. Another thing you could have done, instead of doing this x minus the negative 3 squared plus the y minus the 4 squared, you could have looked at your center and said, in order to move negative 3 back to the origin, I have to add 3 to it, so it would be x plus 3, the quantity squared, and in order to move the 4 back to the origin, I would have to subtract 4, so it would be y minus 4, the quantity squared, and then just the square root of 13 squared, which give you 13. Here's an example that's not in your notes, but I've seen questions like these on assessments, so I would recommend that you write these in your notes. In this question here, we are to find the center and radius of the circle having the following equation: 4x squared plus 4y squared minus 16x minus 24y plus 51 is equal to 0. To rewrite this equation that we have in the standard equation of a circle, you need to recall how to complete the square. So our first step, I'm going to take this positive 51 and move it to the right side, so I'm going to isolate my constant. person. And then I'm also going to group all of my x terms and all of my y terms together. So it's going to look like this. 4x squared minus 16x plus 4y squared minus 24y is equal to negative 51. Now, in order to complete the square, my x squared term and my y squared term have to have a coefficient of 1. So I'm going to have to divide all of these terms by 4, which gives me x squared minus 4x and y squared minus 6y is equal to negative 51 divided by 4. I'm going to go ahead and complete the square. I'm going to have to do this procedure twice, once for the x values and once for the y values. I'm just going to put parentheses over here so I know I'm working with two different sets. I also am going to know, since I'm completing the square, I need some number over here to complete that square, and I need some number over here to complete this square. And since I am adding two numbers on the left hand side, I have to do the same thing on the right hand side. Remember, to complete the square, you take your x coefficient, which is negative 4, divided by 2 and square it. Negative 4 divided by 2 is negative 2. Negative 2 square is 4. So I'm adding 4 here, which means I need to add 4 here. Here I've got negative 6 divided by 2 square. Negative 6 divided by 2 is negative 3. Negative 3 square is 9. So I'm adding a 9 on both sides. Next step is I need to factor these quadratics, and I also want to simplify the right hand side. You need two numbers that multiply to a positive 4 and add to a negative 4, in which case this is x squared minus 2x plus 4. Same thing over here. You need two numbers that multiply to a positive 9 and add to a negative 6, which gives you y squared minus 3y plus 9. In this side over here, in order to add my constants, I need to make sure that my denominator is the same, which means that I need to multiply 4 by 4 and 9 by 4. So I have negative 51 over 4 plus 16 over 4 plus 36 over 4. Factor the left side. This gives me x minus 2 times x minus 2. Here I have y minus 3 times y minus 3. This is a repeated multiplication, so I can just say x minus 2 squared. Plus, here again I have a repeated multiplication, so this is y minus 3 squared. Simplify this side, this just gives me 1/4. And here is my equation of my circle. From this, I can figure out what my center is. My center is the opposite of negative 2, which is 2, and the opposite of negative 3, which is 3. And then my radius is the square root of 1/4, which is 1/2. Example 3 from your notes, graphing a circle. The equation of a circle is the quantity x minus 3 squared plus the quantity y plus 1 squared is equal to 16. Graph the circle. We need to rewrite the equation to find the center. We've got x minus 3 squared plus y plus 1 squared is equal to 16. Here we have x minus 3 plus, since this is a positive, it's the same thing as saying y minus a negative 1 squared, and that is equal to 4 squared. So our center is at 3 and negative 1, and the radius is 4. To graph the circle, place the compass at point 3 and negative 1, set the radius at 4 units, and swing the compass to draw a circle. Another way you could do it and skip this step over here, which the x minus 3 squared plus the y minus negative 1, is to figure out my center, x minus 3. So what do I need to do to the x in order to get back to the origin? I need to add 3 to it to move it back to the origin. So my x value is at 3. And then what do I need to do to my y value in order to move it back to the origin? I need to subtract 1 from it, and so my y value is negative 1. And then for the radius, just take the square root of 16. Example 4, applying graphs of circles. A skydiving instruction school has a field with multiple landing targets. Each target is circle-shaped. A coordinate plane is used to arrange the targets in the field with the corner of the field at the origin. The equation, the quantity x minus 8 squared plus the quantity y minus 4 squared equals 9, represents one of the targets. Graph the landing target. To be able to graph our landing target, first we need to rewrite the equation to find the center and the radius. The equation is x minus 8 squared plus y minus 4 squared is equal to 9. We know that if you take the square root of 9, that's 3, so 3 squared gives us 9. What do I need to do to negative 8 to move my x value back to the origin? And that is to add 8, so my x value is positive 8. And what do I need to do to negative 4 in order to move my y value back to its origin? And that is add 4. My y value is at 4, so the center is at 8 and 4, and the radius is 3. Graph the circle. Here's our circle, which is one of our targets, and its center is at 8 and 4, and the radius from the center of the circle to the circle is 3 units. Part B, the landing spot by the following skydivers are located as follows. Marika is at 7 and 3, Alex is at 3 and 4, Julia is at 10 and 7, and Caleb is at 9 and 6. Which skydivers landed on the target? So to do this, you want to graph all of these coordinate points and see which ones actually landed in the target. The graph shows that both Marika and Caleb landed on the target. Alright, checkpoint problems 1, 2, and 3 are yours to complete. In problem number 1, write the standard equation of a circle with center at -5 and -3 and a radius of 5.2. Problem number 2, the point 4 and -5 is on a circle whose center is at -2 and 3. Write the standard equation of the circle. Problem number 3, graph the equation. The quantity x minus 1 square plus the quantity y plus 3 square is equal to 9. Alright, that's it from me. I'll see you all soon.